Hello, welcome to 2HTV. In today's class, we are going to look at Doppler effect equation. But before that, let's look at the definition of Doppler effect. Now, Doppler effect is simply a phenomenon that occurs as a result of change in frequency between a source of sound and an observer. So normally, what usually comes to mind when Doppler effect is being heard? A practical example is a siren that is blown by an ambulance car traveling on a road and a stationary or moving object. Now, assuming a siren is 10 meters away from a stationary object, the stationary observer or the stationary person will notice that as the ambulance blowing the siren approaches him or her, the sound produced by the siren becomes louder and louder till the ambulance bypass the person. The person begins to realize that the sound is also decreasing little by little at a point of time where the observer wouldn't hear the sound produced by the siren anymore. So this is how Doppler effect works. So Doppler effect is simply the apparent change in frequency between a source and an observer. So Doppler effect is simply the apparent change in frequency is no more heard. So let's look at the Doppler effect equation. This is how it looks like. FO is equal to F subscript X bracket open V plus or minus VO, all dividing V again plus or minus VS. So this is how the Doppler effect equation looks like. Now let's look at what each of them means. The FO is object frequency. The FS is source frequency. Let's look at VO is object velocity. VO is object velocity. Then VS is source velocity. So FO object frequency, FS source frequency, VO object velocity, VS source velocity, and the V itself is velocity of sound. Note that in a given question, when the velocity of sound is not, so you should note that when the velocity of sound is not given, it is 343 meters per second. Now we have 4 cases under Doppler effect. So let's look at that. Let's have our object here and let's have our source here. So this is our object, this is our source. So the first case could be that the object is moving towards the source, and the source also is what? Moving away from the object. So that's case 1. It could be that the object is moving towards the source, and the source too is moving away from the what? The object. The second scenario too can be that the object is moving towards the source, and the source too is moving towards the object. That's the second scenario. The third scenario could be that the object is moving away from the source, while the source too is moving away from the object. The source too is moving away from the object. And it could also be that the fourth case, the object is moving away from the source, and the source is also moving towards the object. So there are 4 instances. So depending on these 4 instances, it will help us to know whether we are adding the what? Object velocity or subtracting. And when it comes to the denominator, it will let you know whether you should add the source velocity or subtract. So let's quickly look at how it works when you know that, oh, when it moves in this direction, I have to add the velocity of object to the normal velocity, or I should subtract, or to know the direction in which they will move, so that the source will be added to the velocity or the source will be subtracted from the velocity. So let's quickly look at that. So with that, we are going to take our Cartesian plane, right? So let's take our Cartesian plane, something small here. We know that this is our x-axis, right? This is also our x-axis. Now our focus is on the x-axis. So our focus is on the x-axis, right? We know that this place represents the positive x-axis, whilst here is the negative x-axis. So take note, we have the positive x-axis, which is moving in this direction. Then we have the negative x-axis, right? Okay, so with this, let's look at how we will identify whether we are adding or subtracting. So we are saying that the object should always be at the left hand side, while the source should be at the right hand side. Now let's look at the 4 cases. Now if the object's velocity is moving in this direction, right, using the Cartesian plane, we know that when it is moving towards the left direction, it should be what? Negative. So meaning that here your velocity is what? Negative. So your velocity is negative when the object is moving in the negative x direction. So it becomes positive when the object velocity is moving in the positive x direction. So take note, negative when the object is moving in the negative x direction, positive when the object velocity is moving in the what? Positive x direction. So same with the source. If the source velocity is moving in the negative x direction, the velocity will be what? Negative. But when it is moving in the positive x direction, the velocity is what? Positive. So take note of this. Keep it as it is. If you change the position of the source and the object, you might mix everything up. Now let's look at the 4 cases that we have. So case 1. Now case 1, let's say that the object is moving away from the source, and the source too is what? Moving away from the object. So let's concentrate on the velocity side, because the object frequency and source frequency is the same. So meaning that first case, our velocity. Now whether we are adding the what? Object velocity. So this is our object, and the object, we are taking this case where the object is moving away from the source, so the velocity is what? Negative. So here we subtract, the object velocity. So when you come to the denominator, we repeat our velocity. Now we are looking at whether we should add or subtract the source velocity. Now the source, in this case, we are considering they are both moving away from each other. So the source velocity is also moving away from the object, and it is what? Positive. So we have to add. So this is how the first case looks like. So you add your F, O is equal to Fx. So this is how your first case look at. Let's quickly look at the second case. The second case, let's say that both object and source are moving towards each other. They are approaching each other. Now, if the object is moving towards the source, the object velocity is what? Positive. Then if the source is moving towards the object, the source velocity is what? Negative. So this is how the second case looks like. So you just add your F, O is equal to Fs to multiply the whole of this in the second case. Now so we are looking at the third case. The third case, let's assume in the equation the object was moving away from the source, and the source too was moving towards the object. So the object is moving away, negative. Then the source is moving towards the object, still negative. So we subtract. So velocity minus velocity of object, then velocity minus velocity of source. So this is how the third case will be. Then let's quickly look at the fourth case. So this remains the same. So the fourth case, let's assume also in the equation the object was moving what? Towards the source, while the source too was moving away. So object towards positive, source away negative. So still positive. So we add both instances. So velocity plus velocity of object divided by the velocity plus velocity of source. So the velocity of object and source would be 0. It will be 0 when it is stationary. Take note of that. So these are the 4 cases. So you knowing the general formula of this, right? So with the object and source scenario that we just did, you know that you can get all the 4 cases, which is this we are subtracting and adding, this we are adding, subtracting, adding. So these are the 4 cases that we have. Thank you so much. Please subscribe. In our next video, we'll be doing calculations on Doppler effect. You can't afford to miss.